Hello everybody, getting ready to do lesson 6.4 of our SAT Math Level 1 prep course today. Email me here for further questions or materials. 6.4, solid figures. We got a 62-point tune-up with this lesson here. And you have 18 points here of note-taking to take. Taking notes is very valuable. Okay, and an overview of this lecture here. The reference section at the beginning of each SAT math section includes the volume formulas for these solids: rectangular box, right circular cylinder, sphere, right circular cone, and pyramid with a rectangular base. So each SAT math begins with the formulas for these solids here. Volume of a rectangular solid and cylinder. So the SAT may include problems that make use of formulas like the lateral area of a right circular cylinder is the area of its curved surface. So like the outside part of this cylinder here, the surface area of that, which is called the lateral area. And it wouldn't include the bases, that would be extra. The surface area of a solid is the sum of the areas of all of its surfaces. So just to know, the good note to take here. So an oil filter has the shape of a right circular cylinder, and say for example it is 12 centimeters in height and has a volume of 108 pi cubic centimeters. That would be its volume. What is the diameter of the base of the cylinder in centimeters? So we have a volume here of 108 pi, and we have a shape of a right circular cylinder is 12 centimeters in height. So we need to find the diameter. So the volume would be pi r squared h of a cylinder, of a right cylinder. We have 108 pi, which is the volume, and then over 12 pi, which would be the height. This would be to find the diameter here. 12 pi times r squared over 12 pi. So we would come out with 9 would equal r squared. So that would give us 3 would equal r in this situation here. So that would be how you would plug in values into a volume formula and then to find the diameter here of that. That would be a way, in this situation here, you had a volume of 108 pi divided by 12 here, of this, which is the height. So we come up with 3 equals r here from that situation. Since the radius of the base is 3 centimeters, the diameter would be 6 in this situation here. That would be one way to find the solution to this question here. A coffee shop makes coffee in a 5-gallon capacity urn and serves it in a cylindrical shaped mugs with an internal diameter of 3 inches. Coffee is poured into each mug at a height of about 4 inches. What is the largest number of full mugs of coffee that can be filled from the coffee urn if the urn is filled to capacity? So we have a 5-gallon urn here. There are 231 cubic inches in 1 gallon. So 5 gallons will be 1,155 cubic inches. Find the volume of each filled coffee mug. So the volume, here's our volume formula again, pi r squared h. So pi times 3 over 2 squared 4 would be our plug-in here to find the volume of each coffee mug. And then when we multiply through, we get pi times 9 over 4. These would cancel here, the 4 and the 4 there. So 9 over 4, these would cancel. So it'd be 9 pi cubic inches would be the volume for each coffee mug. That would be how you would figure the volume of a cylinder. Find a number of filled coffee mugs by dividing the capacity of the urn by 9 pi. So now that we know that each coffee mug is 9 pi, we divide that into 1155 and we get 40.85. So 40 full coffee mugs could be filled from the coffee urn. Okay, into a table. Volume of a cone, pyramid, and a sphere. Type of a solid, diagram, then formula. So this is a good note-taking thing here. A right circular cone. This is a diagram of a right circular cone. You have a right triangle here that provides the height, the base, and then your slant height here would be the hypotenuse of the triangle. And then the formula here would be 1/3 base times height for a right circular cone. And then that would become, the base here would be pi r squared h. So it'll be 1/3, and then your base here would be circular here. So the base, the volume of the base times the height would be pi r squared. So the base would be the volume, or the area of the base times height. And to find the area of the circle, it'd be pi r squared times h would be the area of that circle. Pyramid with a rectangular base. So we have a pyramid here with a rectangular base. The volume again would be 1/3 times the area of the base times height. So it'd be 1/3 length times width times height for the volume of a pyramid with a rectangular base. And then a sphere would be, the volume of a sphere would be 4/3 pi r cubed in this situation here. So very important formulas to take down and to memorize for your SAT. So what is the volume in cubic centimeters of the right circular cone in terms of pi? So we have a situation here. Here's your circle here. And then 13 centimeters here would be our slant height, I suppose. Use the volume formula V equals 1/3 pi r squared h, where r is 1/2 of 10, which is 5. So we know our radius here will be 5. And then we plug that in now into our formula, and h equals 12. H equals 12. So we have a 12, 5, 13 right triangle here. And so 5, 12, 13 right triangle. To find the volume, then we plug into our formula 1/3 pi times 5 squared times 12, which would be 100 pi cubic centimeters for the volume of this cone, right circular cone.